Good day, everyone. My name is Alric Grandison. This stream is a devlog documenting my approach to creating a new programming language to be an alternate option to the C programming language. Why do we need an alternate to C? Well, because C was created over 50 years ago, and because of that, it lacks some very basic modern features that are now expected in most modern programming languages. And that's not a bad thing for C because C maintains backward compatibility. So for codes written 50 years ago should be able to compile and C compilers today for the most part. So backward compatibility is important for C, and that is why it does not change as much. Therefore, Zen, the name of the programming language I'm inventing, is offering a fresh start with all the modern features built in from this get-go, and then it maintains backward compatibility from there. C is extremely important for low-level programming such as embedded programming, and Zen will return all those features, but it will include new modern features such as memory management, which will bring about help to eliminate memory vulnerabilities and memory secure software security and memory vulnerabilities is the focal point of today's software industry. So Zen is going to be designed with the guarantee that it will be 100% compatible with C on an ABI level. And as I said before, it will be an alternate to C. Some of the features we plan to implement with Zen is zero initialization, default zero initialization of variables. So basically when you define a variable, it's automatically initialized with zero. You don't have to do that. We're going to have format strings like in Python. We're going to have multiple returns like in Go. We're going to have unnamed parameters. We're going to have core routines like in GDScript. We're going to have a structure merge feature, and this is a different approach that is similar to inheritance in OO programming without the inheritance. So you get the effects of inheritance without the problems of inheritance. So that is structure merge. Structure association is getting the features of classes without classes. So you can call an object and then the method associated with it, but Zen is not a OO language and it does not have classes. We're getting rid of the include, the C include, the pragma once, the include cards, and we're using a module and import structure. We'll have namespaces. So C, unlike C, which only uses global namespace, Zen will have a namespace structure. We're going to have defer like in Zig and Odin. We're going to have scopeless blocks like in preprocessors in C. We're going to have templates like in C++, and memory template, which is a new feature which is similar to Zig, memory explicit use, memory templates. We're going to have macros, which will be the alternative to preprocessors in C. And we are going to have a raw pointer, manage pointer, value reference, variable reference, and a transition pointer reference model, which is a completely different model from which is Zen's approach to memory, avoiding memory vulnerabilities, managing and automatically manage memory. It's a completely different model. Just like how Russ has the ownership model, Zen has this model, which is not ownership, but it's different. There might be some similarities, but it's a different type of model. Um, Code configuration, very unique feature to Zen, where you can extend statements and commands to mean additional things. And Zen is going to support both inline C and inline assembly. So Zen is going to be a well-suited programming language for system programming and other low-level programming as well as high-level programming because it will have high-level features. Zen is being designed to be a language that can be used to write drivers, kernels, operating systems, and applications and video games, primarily video games because my goal is to write games and that's why I'm creating Zen. So here's an example of the syntax that Zen is going to have. So you're going to have the import and you import from the standard library, the IO module, and then you're going to have this procedure. It's an unnamed procedure that's called print hello world. And then we're actually exporting this procedure to the linker and we're exporting it under the label main to the linker. So linker will pick this up when it's doing the linking. And this export we'll put it in we'll give it a labeled name in our binary, object binary. So this, if you come to my website, it's my website, algodal.com, and you come here to Zen Programming Language. You'll have this introduction to the language and with a license, and right here you can find the link to the full documentation. So you can get it here. So you can come here and read through. So this is the initial design and it is subject to change. But this is most of the design locked down and I'll try to keep it like this for the most part. So I'm in the initial stages of development and I'll be using a LLVM backend like most modern programming languages. So right now I'm working on the parser side. I will not be building a parser from scratch and I will not be using parser generators out there, the common ones like Yak, Bisons, Lex and Flex. I'll be using my own parser generator to design the parser. And this is it. It's called the Algodal parser generator. It is a tool I created and it is commercial. This is not a sponsorship and I'm not advocating for anyone to buy it. This is just I made it, try to make a few bucks off it, and it is what I'm using. If you're interested in learning about it, here's the manual, the link to the manual. You can get that from my website. So you come here, parser generator, and you come here to the manual. And it has a itch.io page. Sometimes I do run discounts and it's a lot different from other parser generator. Right now it does not support grammar files. So, for example, C Sharp uses the Annex A grammar style, like this. And here is another example. This is the XML grammar. And this is, I think this is EBNF grammar. Is that what XML uses? And then you have the Lex and Flex, Lex and Yak grammar. Right, so the reason why I created my own parser generator is because whenever I was writing a parser, I used to write parsers by hand. I found that process to be extremely tedious, and then I found the Flex and Bison parser generator, which alleviated a lot of the work, but then it was still tedious because it was very tedious to set up the parser generator. And then a lot of things you had to do by yourself, except for example for the generation of the abstract syntax tree, you had to write the code yourself to generate the abstract syntax tree. So it was very tedious. So that is why I created my own parser generator. And the goal of this is to generate parsers for any type of language very quickly. So you had the token phase, the syntax phase, and here you wrote the actions that created your tokens. Here you wrote the actions that created your syntax, and you put it all together in the config section. And then what it did, it generated C files, and then you will compile those C files into your parsers. My internet's going a bit slow. It's done through an app, and yeah, and then you can have a nice simple parser. So this is what I'm going to use, and this is a software that I'm still working on improving. I do have some new ideas that I want to implement. So now this is sponsorship. So I do have some new ideas I want to implement. I I wanted to support grammar files because a lot of people who need parsers like the idea of writing their parsers in an established grammar file format, and then can generate their parsers from that. And I wanted to also support like languages that uses spaces like Python and YAML. Right now it doesn't support those type of languages, only block type languages like JSON, C. Yeah, so this is what I'm going to be using. Okay, so let me just get some of these web pages out of the way. Excuse me. All right. Okay, so I talked about my parser. It's been a long time since I used it, because since the last time I update this parser, I have not touched it. So I found myself having to go back to the manual to try to get myself up and running again. And okay, yeah, this is the, let's see. So I've already set up a few things. So this is the project. Right now it's a C project, and these are generated by the parser generator. And I have a few files that I'm working with. This is a special make file for copying files. If you would like to get a copy of this, you can get it. Let me show you where to get it. So if you go on my GitHub page, why is my internet going so slow? I think it's on my home page. Yeah, so if you go to my homepage on GitHub, you'll see CMake extensions and you can download it here. Here is it. It's a really handy CMake file for copying files. Really handy, really useful. It was written by me, so feel free to use it. No attribution needed. Right, so let's get back to this. So right now I'm working on the Lexer, and I have this is the parser so far that I've written. So I'm tokenizing these strings. This is the example data I'm parsing, and this is so it we're including the generated file from the parser generator. This is just a helper function I wrote for opening a file. So all I'm doing is just opening a file and returning it. Um, oh, and right now, guys, this is closed source. The compiler I'm working on is closed source for the time being, but everything else is open source. What I should say, it's what does it call it? Yeah, it's closed source for the time being. Right. So yeah, this is a parser so far. I and these right here is generated. So this is generated by the parser. So it my parser generator takes this code, which is my parser generator code that you write, and it generates these three files. These are standard files that are dependencies, but this is a file that is generated based on what I have here. This Zen program file, whatever. So generate that, and then you have the VM that runs it, and then you got the header file that has the declarations that is needed if you're going to use it. And then here I have that same header file, and then these functions are all parser generator functions. So I open the I read the file. So this is the file. I read the file and save the length, and I pass it to this function called get tokenized result, and it gets me the results. I pass it to this function to get line numbers, and it generates some line numbers. Then I group it together here. Yeah, so this is another thing I need to do. I need to update the API better because I think I might have made a poor design choice when I was creating the API for this parser generator. And then I print out the results. Then in my CMake, I am compiling the generated files into parser. I compile my utils, I compile the text lexer, and then I combine them, and then I'm copying the files from my source directory into the binary directory so that when I run the binary, it can read the files. And yeah, let me actually do that. See if I come and create. Okay, because I'm streaming, my system is moving slow. So if and by the way, guys, for this project, what I did, I created a build folder. I did a cmake d cmake type equal debug dot dot dash g mingw. So I'm using mingw to compile on Windows. Because I'm building this project to be cross-platform, and then I go in the build folder and I just run this to build it. So that's how I set it up. Right. So if I go, I can go test Lexer, think, yeah, and there it goes. We're parsing the text, which is this here. So I don't need to keep this open, I just need this. And I need this. Okay, so let's do this. We can start here. So remember, I'm not creating a grammar file. In the future, when I update my parser generator, I probably will create a grammar file for Zen because I know a lot of people out there that like grammar files. For now, the only file that we're making is the Zen parser source file. And this is the this is the Algodal parser generator app. So I pass the source file, as you can see here, and I pass where I want it to generate the C files. And I just hit generate and it generates the files. So I am going to, oh, and I need this guy, right? So I'm gonna update this. I think I'll just use this file here so that I don't have to switch from VS Code. So import is a keyword. So the way this would work now is that I'll have to come here and in order to get this syntax highlighting, you will download the Algodal parser package. Here it is. Algodal parser. Yeah. So this package will give you the syntax highlighting. Okay. So continuing, doing token, and I think the way this works, it's been a long time since I used this. Been a long time. Is add action, the name of the action, and then the logic in between angle braces. So we're gonna do the should I give it a label? Hmm. I'm just wondering how to design, because I can design it in more than one ways. I could put this in a variable, or I could let it remain as an import string. I think I'm gonna let it remain as a string. So I'm gonna say, okay, import. So right here, I'm gonna import the keywords, right? So import, we'll go there. Export is a keyword, proc is a keyword. Proc is a keyword. Export is a keyword. FN is a keyword. What other keywords are there? Okay. Keywords. So we got key symbols. So we'll do key symbols. We use hash or pound key dash dash for line comment. Then we got dash dash. This is for open block comment. Close block comment. See there. Of import. We haven't done string yet. I'll do string after. We have the terminating this guy, statement terminator. Okay, and then we got these, the types. So we got bool. As a matter of fact, I think I want to group this. Do I want to group this? Alright, never mind. I won't group it. Bool. And then we got B01. I'm not 100% sure if I'm going to support these quite yet. But for now, they're part of the design. So I'll include them. B001. B002, I think. Sorry, 4. 4 and 8. 4. B008. B016. B032. Then we got signed character, unsigned character, CHR, UCHR, SINT, S008, I think. Okay. S016, S032, S064, and there's a possibility we might support S128. But for now, I think I'm not including it. For now, I think I'm not including it. Okay. So UINT, U008, U0016, U032, U064. Okay. Okay. And then we got real. So we got R real and then void. So 32, 64, 80. So we got real R032, R0, I think 64, R080, and then we got void. So that rounds out our primitive types. We're not doing that yet. Let's focus on keywords and key symbols. So we got the format string specifier. So that's I think we have a backslash means something, so I think I have to use double backslash. I think F. I need to check this. So let me compile this. So I'm gonna hit generate. Detects an error. So at line 41, at config error, syntax error, unexpected config, expecting label, no tokenizer found. Okay. So basically, I need to delete this. Save. Hit generate. Generation completed. Good. And I think this should, yeah. So Zen program. So this didn't change, but the program changed, as you can see. So if I come here now and I do cmake build dot uh, mm, mm, um spelling. I hope I hope you guys can see my screen. Probably should make it bigger. See. Okay. My computer is running very slow simply because I'm streaming. Okay. So it builds the parser over because this is updated. Then it's copying the files back. And then it's rebuilding the executable. Okay. Let me also increase the size for this. Make sure. And then I'll just run this like so. And this should fail, as you can see, failed because now we are, I don't know, actually, now we're actually look searching for this text and it's looking in this and it's not seeing that. So if I put something like import, it should work. Nope, that's weird. Have import, right? Yeah. import. Let me see something. Put space. Oh, I know why it didn't work. Because this is this is in here. It's not in here. It's just the one that was copied. So to ensure that whenever I make a change here in this file, to ensure that it's copied, I have to build it. And there we go. It copies it. And now, right, there we go. It works. It parses import. So what I'm gonna do from now on is that I'm gonna do a cmake build dot and then I do and dot Um, test selector. Alright, so that I always remember. So I want to test this. So oh, I think I made a mistake. It's backslash, and I think I put, was it backslash I put? Oh yeah. So I want to test this because I don't remember something. Okay, let's try that. Um, oh man. Yeah, I am thinking I'm working on Linux. This is Windows. Wonder if it does it. Nope. Yeah, Windows and Linux don't do things the same. How do I do this? Hmm. Hmm. Give me a second, guys. I need to check something. Just give me 1 second. Okay, guys, I'm back. So, let me see if there is any alternative on Windows for this thing. Um, yeah, it is. I don't know why I'm getting error. Okay, so yeah, I don't really got time for that. I think yeah, I just can't be bothered. This is why developing on Linux is better, because you can just do stuff like that. Okay. Okay, it works. It works. Okay. Just wanted to confirm that. So, putting slash slash. Okay, that works. that works nicely. Great. Okay, let's continue. Um, okay, let's continue our raw strings. So we need one for raw. So okay. And the range specifier. So I need one for the range specifier. Then you have the operators. You got the equal sign. You got the plus. You got the minus. You got the is it this yeah this one. Yeah, you got the divide. You got the multiply. Then you also have the not symbol. You got the is equal to, is not equal to. You got the less than symbol. You got the greater than symbol. You got the less than and equal to, greater than and equal to. You got the I don't know if I'm gonna have a plus plus operator yet, but I do know I think I'm gonna have a slash slash operator. But you tell you what, let's leave that out for now. Yeah. Oh, and there's gonna be a dot access modifier as well. Okay, so let's drop in a lot of stuff there. Okay. FN is a keyword. Did I put FN at the top? Yes, I did. Okay. Okay. Oh, and then okay. So I'm gonna have the array specifier. That yeah. We have the value specifier. That. Oh, we got brackets. Oh, we have a lot of symbols. We got the reference symbol. We got the pointer symbol. We got the raw pointer symbol. We got the variable reference symbol. We got the configuration symbol, and we got the source string symbol, and of course we have the string symbol. Oh, we got the parameter access symbol. Okay, any other symbol? No, I don't think so. Let's see. Oh, the underscore symbol. Okay. Underscore symbol. Okay. Okay, so for keywords, we need to drop in or and, or not. Oh, sorry, we don't have not. It's and, or, zor. Um, assembly is a keyword. True and false. Oh, true, false, if. True, false, if, um, when, which, do, while. Bar symbol. We got in and for. In, for. Okay. We have the apply symbol, which is this. Mm-hmm. Oh, use keyword. Use. Oh, with. Oh, yeah, we got with. We got then, and we got end. We got macro. Oh, we got memory and type. Memory, type. And we got type off. And we got struct. Got struct. It looks like I forgot to add these to the documentation. We have struct, we have enum, and we have union. We got this thing where we have that. Okay, So we have all the tokens. So for where it is, it's for the symbol token. For this one, I'm gonna remove this because it's not just that it. Okay. It has to have a number beside it, and the only way to represent that is using an action, and I'm gonna call this the parameter var, say parameter variable, and it's gonna start off with this, and it's gonna need to have a any counting number, and a counting number is gonna be one or more, one off, and 1, 2, 3, 4, 5, 6, 7, 8, 9 as a counting number. We also have parameter return var, which is this plus a negative whole number. So a negative whole number is 0 or 1 or more, or minus counting number. Okay, and we're gonna have this and this. That will be what? Symbol of parameter var and return var. Okay, and we're gonna have string. So I'm gonna have action. Let's call it line string, and we're gonna have string followed by, we're gonna terminate with a string. Now in between we can have 0 or more, and not anything that is not a string over Put this first. Only dash that string. Yeah. Sorry for the noise, guys. I got a neighbor who is excited. Anyways, guys, so basically I'm refining the tokenizer. So where I have right here, I'm removing this and I'm creating a function that tokenizes an entire string. So let's put that to practice and see if it works. So I should be able to tokenize the very first code in the documentation. This code. So let's see. And this is why I think my parsing generator is far more superior, because look how quick and easy it was for me to write all of this stuff. And it's just gonna generate the parser for me in a few seconds. Okay. Now hit generate. I have an arrow. Oh, it's not being used. So, see, I created this, but it's not being used. So this should go under symbol. Yeah. So line string. So generated. Now compile. Oh, my system is moving slow from the stream. I gotta have to check if there's a way to optimize my stream using my GPU, because this is a gaming laptop and it has a GPU. Right, there we go. And let's see. Nope, failed at 1.7. What is in 1.7? Oh, wait. This is one, yeah, 1.8.1.7. Oh, it is not parsing space. Oh my goodness, that is so ridiculous. I could put a simple space there, but I could do this. I could do this. But I think it will be more efficient, because this is not like Python where space is important. It's like C. So I can group all the spaces and just parse them. So space, and I'm gonna do one or more. So this symbol means one or more, guys. So if we come to the manual, uh, do, 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 do. If I come to the manual, and here the count function is the brackets and write it here. You see, we'll run the command one or more times. Run the command zero or more, 0 or 1, 2 to 7, 5 times, 3 or more times. Right? So one or more, one off, either this, this, or this, or that. All of that is a space. So I run that and I put that here. Space. And let's go and build that again. Oh, I made a mistake. I forgot to regenerate. So each time you update the parser source code, you have to regenerate from that source code. Go. I probably could automate it where as I edit it and then I run build, it automatically because it automatically generated for me because this has a console app. It's not just GUI, graphic user interface. There's a console version for it that I can use, and yeah, but I won't do that approach. This is fine for me. It's already generated. So let me build again so that it builds with the generated code, updated C code. And there we go. And we can run. Nice. So we see import is sparse, space is sparse, line string. So far, and we failed at 4 5 simple because 4 5. Oh, because we have not put any parse for labels yet.